Imagine driving your car directly into the Baltic Sea. You are 40 meters underwater. Above you, there is no sky, only millions of tons of freezing ocean water crushing down on a concrete tube. There are no bridges here, no ferries, just the longest immersed tunnel in human history. This is the Fehmarn Belt Fixed Link, a €7 billion gamble to physically connect Germany and Denmark. But unlike the channel tunnel between the UK and France, they aren't digging this one underneath the seabed. Instead, they are building 89 massive hollow blocks on land, each weighing as much as an aircraft carrier, floating them out to sea and deliberately sinking them into a trench on the ocean floor. It sounds impossible. If a single seal fails, the tunnel floods. If the alignment is off by just a few centimeters, the connection fails. This is how Europe is building its most dangerous shortcut, and why this engineering marvel might actually be a logistical nightmare. To understand why anyone would attempt this, you have to look at the map. Germany and Denmark are neighbors, yet traveling between them has always been a headache. For decades, the primary route between Hamburg and Copenhagen has relied on a ferry service across the Fehmarnbelt Strait. It's slow, it's weather-dependent, and it creates a massive bottleneck for trade moving from Scandinavia to the rest of Europe. The promise of the Fehmarn Belt Tunnel was simple: delete the geography. By building an 18-kilometer direct link, the travel time by train creates a teleportation effect, cutting a 5-hour journey down to just 2.5 hours. But originally, this wasn't going to be a tunnel at all. Engineers first proposed a massive suspension bridge. It would have been cheaper and easier to visualize, but the Baltic Sea is treacherous. High winds would shut down truck traffic for weeks every year, and the risk of a massive container ship colliding with a bridge pylon was statistically too high to ignore. So they chose the harder option. They decided to go under. This is where the reality of the construction becomes staggering. Most people assume underwater tunnels are built using giant boring machines that drill through the earth, like the London Underground or the Eurotunnel. But the soil here is too soft, and the distance is too great for that method to be efficient. Instead, engineers are using the immersed tube method. To pull this off, they had to build the world's largest tunnel factory in Rødbyhavn, Denmark. This isn't just a construction site, it's a manufacturing plant the size of a small city. Here is the process, and it is brutally complex. The tunnel is made up of 89 standard elements. Each one is 217 meters long and weighs 73,000 tons. They cast these segments in a dry dock on land. But moving a concrete block that heavy is a physics problem. They use hydraulic jacks to compress the tunnel segments together, sealing them tight. Once an element is ready, they flood the dry dock. These massive concrete blocks are hollow, so surprisingly, they float. Tugboats then drag these floating behemoths out into the open sea. This is the critical moment. Beneath the waves, a fleet of dredging ships has already carved a trench, an 18-kilometer scar, into the seabed. Using steel cables and GPS systems with millimeter precision, they slowly lower the element 40 meters down into the darkness. It has to land perfectly in the trench. Once it connects to the previous section, the water between them is pumped out, creating a vacuum seal. Then, they cover the roof of the tunnel with sand and rocks to protect it from ship anchors and currents. They have to repeat this process 89 times, without a single mistake. So, where do we stand today? The project is officially under construction, with the first element scheduled to be immersed soon. But the smooth sailing narrative sold by politicians has hit the rocks of reality. First, there is the cost. Initially estimated at around €5.5 billion, the budget has crept upward, now sitting closer to 7 or 8 billion, depending on how you calculate the supporting infrastructure on the German side. While Denmark is paying for the tunnel itself, Germany had to upgrade its road and rail networks to handle the new influx of traffic. This sparked years of legal battles in Germany. Environmental groups and ferry operators delayed the project for nearly a decade, arguing that the construction would destroy the marine ecosystem of the Baltic Belt and bankrupt the existing ferry businesses. There is also the question of risk. Unlike a bored tunnel, which is deep under the seabed, an immersed tunnel sits in the seabed. While covered with rock, it remains more vulnerable to external threats, whether that's a sinking ship, a dragging anchor, or even potential sabotage of critical infrastructure, a concern that is much more relevant in Europe today than it was when the project was designed. Despite the delays and the ballooning budget, the Fehmarn Belt Tunnel will likely be a success story when it opens. Just like the Channel Tunnel between the UK and France faced skepticism and financial trouble before becoming indispensable, this link will permanently alter the logistics of Northern Europe. This tunnel changes the math of logistics. It makes rail freight viable again, taking thousands of trucks off the road and reducing carbon emissions. But it also teaches us a lesson about modern megaprojects. The engineering is rarely the hardest part. We know how to pour concrete and sink ships. The hardest part is the decade of politics, lawsuits, and funding disputes that happen before the first shovel hits the ground. When you drive through that tunnel in 2029, 7 minutes from coast to coast, remember that you are driving through the middle of the ocean, inside a concrete tube that took 20 years of fighting to build. But looking at the price tag and the complexity, it forces us to ask, is saving 2 hours of travel time really worth 7 billion euros? I'll let you debate that in the comments below.